Well, first of all, welcome everyone. My name is Diego Barahona from the city of Covalent. Covalent, we focus on managing blockchain infrastructure and overall making blockchain enterprise easy for your companies and the products that you have. We basically offer an end-to-end platform so you can create contracts and deploy them easily. So Convector is part of the efforts that we do to make blockchain development really easy for anyone. So the Convector suite is actually a set of tools that we have developed for developers to be able to create contract systems and test them very well pretty easily. It's all open source. Convector itself is added as in the Hyperledger Labs project. So we are in the process of making it a fully fledged Hyperledger project at the moment. We're talking with the Linux Foundation on the process on how to do so. But right now, actually, the host of the main repository is Hyperledger Labs. So it's all open source, as I said. You can just go and check it out. Let's see, okay. Just to mention a little bit about what we do, about Covalent does. We typically come and move clients away from an environment where they are all logged in the blockchain provider, in a single cloud provider, running all the blockchain components in a single cloud provider. Sorry, which is basically the typical scenario that you will find in a blockchain as a service. And we move away from that to manage remote environments. We do remote deployments, so each of the participants can have their own blockchain, their own cloud provider, and host the blockchain components in different cloud providers to communicate with them. So we basically decouple the blockchain components from the computing infrastructure. So at the day on the day of tomorrow, if you want to just move away from your current cloud provider, you can do so without having to lose all your network connections. We offer all the services and all the tools to be able to do this. We also offer monitoring and security on all the environments that we set up, and so you can have like all your development, testing, and production environments with us, even on different clouds, if it's necessary to do so. A little bit about. So it's in the chat. The recording will be the recording will be available. Is anyone able to hear me?
Yes, we can hear you.
Yes, okay. We can hear you.
Okay, cool. So our typical customers come with an idea of a project just like this. Just example, we have in this example we have a patient that will submit a claim to a provider, a clinical provider, and they will use the Hyperledger Fabric network to persist and validate all these claims from the patients, and the insurance companies can just approve or deny the claim notification, and then all this is going to be transacted on the Hyperledger Fabric. We focus on helping our clients architecturing the problem, developing the solution using Convector and the tools that we have around, and having it very well tested on having unit tests and end-to-end tests and all the stuff with Convector. But we also help them like doing all the deployments of this solution using their continuous integration and even monitoring the environments. Some of our clients are even building interfaces about blockchain using our tools. So this is just to mention a little bit about what we do. We also offer Hurley, which Hurley is also open source. You can use Hurley to install a Fabric network in your local to test your contracts, the contracts that you use with Convector. Actually, we have a Convector CLI, and it already comes enabled with Hurley. So you can just start a network in minutes instead of like figuring out how do I start a network to test the contract that I'm doing. We offer Hurley for that, so you don't have to even worry about all the complexities of setting up a local network. We use Docker for this, and with this we enable even hot reloading of the contracts and live debugging of the contract. So if you want to just put a breakpoint in your code and see what's going on inside a transaction happening on your network, you can do so. And on the final step, we have the deployment section uh, to deploy all the contract that you use in this develop and debug phase to a cloud. It can be either a single cloud just for testing, or it can be on a production environment connecting with multiple clients and making the network between them. About the last step, we support right now Hyperledger Fabric and core down on a beta phase. We're on the process to adding more support to more blockchains, um, and it can run basically anywhere on any major cloud provider or even your on-premise Kubernetes. To talk a little bit about the example we will be covering today for the presentation on how to use Convector, uh, we're going to use this process to uh, give traceability to coffee. So just explain the example to a high level. We got a couple of coffee producers. Sorry, let me see the chat. Yeah, recording will be about. Just to give a little bit of context, we'll be having like multiple coffee producers that will collect the grains and they will export them in a package of a certain amount of size. And they will sell all these packages to a roasted coffee company. Well, it's going to combine all these batches of coffee from different participants. And at the end, they will be just delivering a single product made of all the packages that they got exported from the initial producers. So at the end, we will have is all the information of this final product and what is the composition of each of those participants, like how much amount of this coffee comes from Bob's batch, and all the information about this batch, like the height of the ground, the quality of the coffee he exported, and things like this. So this is just to give you an example on how you can like handle multiple steps in the process and multiple data in the smart contract process. Yeah. So without more, let's check out a little bit the source code of this. I actually have a repository, so you can have the source code for the entire solution that I'm doing today is hosted in GitHub, and you'll be able to access the presentation as well. So in here we have the code where we can generate this with Convector a new project just by doing something like conv new, and then we set up a new name, coffee. In this case, if I execute this command, it will produce me a project looking like this, and with an already initialized package containing all the necessary code that I need to start like developing contracts. What I already did is went through and added a couple of more files to the project to make it more rich. We're going to review this in detail. Basically, in Convector, you have two concepts. You have models and you have controllers. We base this in a pretty predictable pattern. The modeling controller pattern. Everyone is like pretty aware of this on the software industry. So a Convector model is essentially a set of properties, a class full of properties describing how the data will look like on the blockchain. When it stores the data, how it's going to look like. We use TypeScript for this, which TypeScript is based on JavaScript. And we use this kind of decorators that the next generation of JavaScript has enabled to provide validations on the data that you are modeling in this model. So for example, a couple of one that I mentioned is if we set up a property with a read-only, it will only allow you to set up this property once in the blockchain. And if you're trying to um, set this property with another value, the Convector framework will reject this transaction for you without you having to do too much work. You can have decorators like require. So if at the moment of saving this contract on the ledger, this value is not present, it will reject your transaction and things like this. We can also do cool things like validations, and you can see that in here, to validate the data that we are saving on the ledger. So we use Jup. Jup is a JavaScript library. You can find it on GitHub, and our NPM is open source, where you can just describe any kind of validations that you have for your data. In this case, I'm saying, okay, I need this data to be a string and to be one of the values that I'm passing in here. This code structure that I have in here is just evaluating that it can be only one of those two properties that I have in this. But you can have other kind of validations, like for example, in this case, the weight, I want it to be a number, but I don't want it to be lower than 0. So you can write any kind of validations. You can send like an email, or familiar with development, you will receive all the parameters as strings, and then you need to parse all these parameters to the expected value that you want, and then you need to validate if those values are correctly or not. On Convector, we provide this kind of tools or helpers for you to don't have to do that every single time on every single transaction. Instead of that, you just do that once in the model in here. So let's review the controller a little bit. The controller is again another class that you extend from Convector, and here you just define methods that will be able to invoke from the outside world, like and yeah. So you mark with this decorator invocable all the methods that you want to be invoked from the outside, like when someone is sending a transaction to your smart contract, they will be able to invoke these kind of methods. You can have additional methods in your class that those will be kept private and won't be accessible if they don't have this flag of invocable. In here, we use the same parameter. We use the same pattern as in the models. We provide you with decorators. For example, in this case, we provide you with a param decorator that will say, okay, I'm expecting a string for this parameter, or I'm expecting this object with this object is actually a model, a Convector model. So Convector will validate that when someone is invoking this function, it will check the amount of arguments that are giving you to this function. If they don't match, it will reject the transaction just right away. It won't even start executing this function at all. Or if they don't match what the value that you were expecting, you can trust that whatever comes here, it was already validated and parsed. A little bit about the code logic that you can find in a function is really straightforward. In this case, we're trying to register a grain batch. It's a coffee grains, remember? So the logic in the Convector functions almost is pretty much small because everything is already parsed for you. You just need to like focus on your business logic. In this case, I'm just confirming that it's trying to get one of these coffee grain batch based on the ID, just to make sure that the coffee grain batch that I'm about to create, it doesn't exist already. So I'm checking if this idea already exists, and I'm just throwing an error. And by throwing an error, I'm just rejecting the transactions. If otherwise, if it doesn't come in this if condition, I'm I'm going to call this participant get from fingerprint. Actually, let me show you first this participant smart contract because I haven't do so. So actually, let me clarify this one first. In code, you can have multiple chain codes or multiple packages with controllers and models between them. They can be instantiated in the Hyperledger fabric as a single unit, as a single smart contract, or you can install them and instantiate them differently. So in this case, I will be instantiating them in the same chain code package. This is the convenience that I have to use Convector. Um, in this case, I have a model again for the participants. Participants will only have a type, a name, and an identity. The identity will be a string with the fingerprint of the certificate that I want this participant being controlled. So when someone is sending a transaction to the Hyperledger Fabric, they have to sign this transaction. They have to sign this transaction with a private key, and they will provide me a certificate. And a chain code, when the transactions gets to the chain code, this certificate will come as a fingerprint, and I can read that fingerprint and to identify the users. So what I'm storing in this property is the fingerprint of the user that is invoking. So I'm assigning a property, an identity to this participant. So later, when someone is invoking any other function in the code, I can identify who participant is doing what based on this fingerprint that I'm getting. So I have this function in here, get from fingerprint actually, that will basically do a query to the coach to find the fingerprint that is stored in the database, so I can identify the participant that is calling my functions. Um, Let me see this. Yeah, this is actually where I'm registering participants. In this method, I am just getting a parameter participant where it gets me the full object with the model, the type, the name, and identity. And I'm just checking this participant does not exist before and assigning to this identity field that I was talking a little bit ago. The property descender, and descender is that property with the fingerprint of whoever is invoking this function. So this way I can just verify if a user has the permissions to do certain actions or not. And in the case of the coffee batches, see, um, I just want to get a participant model that was already previously registered on the network, using this fingerprint that is the one invoking this create grain batch function. If I am able to find one participant, then I'm assigning that participant as the owner of the batch that I'm about to register in the blockchain. And after doing all these kind of modifications and check-ins, I can just do batch.save, and this will save and persist the data in the Hyperledger Fabric. So as an overall, this is more of the flows that you use in your controllers. The logic will always be pretty small because all the parsing and validation was done already. You just need to verify your business logic, right? A little bit of about how this looks like on the consumer side. So Convector is made of, so you can use the same controllers and models that you already did for the blockchain. You can use that for your backend project. You can use that for your frontend project without having to change a single line of code of those packages. So this is a unit test. Convector is built around unit testing and end-to-end testing. So you can just have all this already for you generated when you generate the project the first time. Essentially, what we're doing here is we create an adapter. Convector is made of an adapter. In this case, we're using a mock controller adapter. The mock controller adapter will tell you that you are going to interact or test your controllers not using a real life blockchain, but using mode and in-memory ledger that you will be building just to run this unit testing here. So this smart controller adapter comes from a package from Convector itself. And you initialize the adapter just by saying what controllers does it have available for this unit test session. And then you create some fake participants for this ledger. And at the end, you take the participant controller, which is, if you remember, was the controller I showed you before about participants. We prepend the call with this special function with a user to specify which user I want to make the invocation. This is the piece of code that will change who is the sender for each of the transactions. Remember that this sender I was talking about. And I will call the register function of the controller. You remember the register function was expecting a participant. And in here, I'm calling the register with a new participant. And to this participant, I'm just passing an ID, which is just a random generated ID for this unit test, and a name. And I'm doing the same thing for this producer B and for the toaster, which actually toaster is not the right, it's roaster. I'll change it back just to don't break the unit test, but I made a mistake in here. So I'm registering 3 participants to demonstrate the unit test to be running correctly. And I'm specifying each of the steps that I have to take care in this unit test. For example, you should create a grains batch. In this case, I'm creating a new model with a coffee grain batch. Remember, we reviewed that before. And I'm specifying all the properties that it needs to specify. In this case, I'm generating a unique ID, a unique random ID. I'm setting the location to be on San Jose. San Jose is the city that I'm locating right now here in Costa Rica. I'm specifying the height of this batch, the height above the sea level, just some random number here. And I'm specifying all the producers, all the participants that were involved in this coffee grains batch. So it can have the information about, okay, this batch was generated by X and Y participants of the network. I'm setting a price and a weight of this package of the batch that I'm exporting. I'm setting on the quality. If you remember, the quality was one of the 2 values, premium or standard. And yeah, I'm setting the date where it was created. So just with creating this batch, I can just now call the coffee controller. You remember the coffee controller wasn't here. Again, preparing this call to be able to do this with using the producer A identity, fake identity in this case, this is a unit test. And then I'm calling the create grains batch with this batch. And just by doing this line, this small line, what it will do, well, for the mock test, it will send a transaction to a fake peer and it will run all the validations. But in a real life blockchain example, like running on a network, which we're going to review in a couple of minutes, it will send a transaction to all the peers in the network or all the peers that need this transaction to be sent. Wait for the responses, and once they get the response, it will then send all the responses, if they were correctly, it will send all those responses to the orderer. And once the orderer approved this transaction and it was already added to the network, Convector, it will like notify the JavaScript engine about this. And so like in here, it will data not in ledger. But when it gets to this line, the data is already in the ledger. And so this is pretty useful because you can just do predictable things about if my line of codes even reached to this section, I can trust the data was already stored in the ledger. If it fails for some reason and it doesn't get to this line, I know it was because something happened on this transaction. So, and you can just do regular things like programming things like wrapping this in a try catch, and you will get the error in here. And if you get the error, you will get an object exposing all the responses from the different peers and seeing which one was the one that failed and why that failed, and things like that. If, for example, if we throw an error like this error in here, I will be able to access this error from here, from error, I think it's responses. Responses is an array of all the responses that I get back from the peers, but I can iterate them, and if all of them failed, I will be able just to pick the first one and get the actual error. So with this, I will be able to access the error that I sent from the chain code, right? So this is pretty convenient. And at the end, I'm just doing regular stuff. Let me see here. Yeah, in here I'm making another call to the controller, but this time I'm not preparing it with the user. I'm preparing it with a query. This call, what this modifier will do is, instead of sending the transactions to all the peers waiting for a response, and then send back that to the orderer to complete the transaction as a whole block. What it will do is just invoke a single node, one of my own nodes, and evaluate this contract call, this contract invocation, and return the result back to me. So I use this query method, this query helper, when I don't want to produce an extra transaction in the ledger, because in this case, I just want to get the grains batch that were already registered on the ledger. So prepping calls with this query will make sure to not produce any extra transaction on your blockchain. And so I'm doing this just to get the grain batch again. I'm saving it and checking that it exists. This completes the full testing of a single grain batch. This one that I have in here is a more complex one. I'm creating multiple batches. This batch is with producer A and producer B. This one is just from producer A, and this one is just from producer B. I am creating the grain batch for all of those. I'm then later creating a model that I haven't shown you yet, which is this roast batch. I misspelled the toast. This roast batch. The roast batch will have a proper decomposition, and it is expected to have the IDs of all the grains batch that is this batch is going to be made of. If you remember the presentation, we're going to combine multiple batches from multiple participants into a single product, right? So we want to be aware of the composition of how much amount of this batch and how much of this batch and this batch are going to be combined in this silo, and then being roast and produce the finalized product, right? So the coffee grains portion model is the one that we want to look for. It basically is made of the initial grains batch ID. It is made of the roast batch ID, and it is that set off by the amount of weight that I use in this mix from the original batch. So I can split the batch. The batch can be referenced into multiple roast batches production because I can just take 10% of the whole production from Bob's and 50% of the whole production of Lisa and things like that, and combine that into a product. This is more like realistically what happens in the real world on the coffee production. We don't just use the whole batch on a roast batch. We use just a single portion of it. So we continue with the test. Let me see where it was. Okay, I was in here. So I'm creating the toast batch, right? The toast batch model. Just specifying all the properties that I want, the price that we'll have, the create date, and things like that. I'm also creating this toast batch, and I'm passing as an argument all the portions that corresponds to this roast batch that I'm creating. So I'm specifying, okay, I want 50 kilograms of this batch ID 1, 80 kilograms from this batch ID 2, and 20 kilograms of this batch ID 3. example. And yeah, with this line of code, again, I'm invoking the chain code and sending the transaction to all the peers and waiting for it to be added to the network. And after that, well, since this is a unit test, I'm just getting to the raw adapter to extract that information and make sure it was already saved. But I'm also like querying the fake network that this unit test is creating for me to get the batch ID, to get the full model. This is a function that we haven't seen yet. So create toast batch, yeah. Get toast batch, okay. So the get toast batch function we just get a batch ID. It will query the ledger to get that batch that we just saved. If it's not found, we will throw an error that we cannot find any batch with that ID. If nothing happens in here, it will continue the execution. So I will be just querying the batch composition. Do you remember the array of IDs that we have about composition? I'm querying all those portion batches by the ID and get the participation based. Yeah, it's a calculation based on the weight of my batch and each of the portions to the corresponding original grains batch. At the end, I'm just returning an object, as you can see here. And whatever I return, this is something I haven't mentioned, whatever I return in a controller, it is what I will get back in the response in the client who is invoking this transaction. So if I go ahead and run this unit test, so do that, VM run test, I will be able to see the response will be just the batch, blah, 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 is made of a certain amount, a certain percent from the batch A, which is, well, actually, let me show you that with the actual response. All right. Let's see, it's in here, yeah. Batch, and then the batch ID is composed of 33% from this batch, whatever, which was produced on San Jose, 100 meters above the sea level, and this is produced by the producer A and producer B. Same thing with this one. This is one that is 50%, which is only from participant A, and 30% from producer B. So at the end, what I want just to show you in this contract is that you can just have multiple models. You can have reference between those models, and you can composite your data structure as you need. Like if you are familiar with non-SQL databases, like MongoDB or anything like that, you can think of modeling data just on the same thing with Convector. And we allow you to do so and to test your controllers just by doing regular implications like this and regular queries like this. So you can test your data structure. You can be composed of multiple reference between documents or embedding documents inside other documents and things like that. So it's very rich, and you don't have to worry about the underlying like blockchain complexities like parsing, validating, all this stuff. Convector also has some unit tests, some end-to-end tests, sorry. I told you Convector comes enabled with Hurley. Hurley is a development environment that you can set up locally. So if I type in here, so in here I run the unit test, right? But this was using a fake ledger. What I'm going to do now is I'm calling npm run and restart. You can see all these commands in the README, actually. So to set up a project, to set up the network the first time, I have to run npm I to install the dependencies. I already did that. But I'm going to run and restart. And restart, what it's going to do is I have Docker running in my local machine. It will try to set up a network of Fabric using my local Docker. And after that, I can just go and run npm run cc start coffee. So this is to package, to build, package, and deploy the contract that I just showed you in the code. into this Hurley local network of Fabric. And at the end of that, I can run npm run test end-to-end, so I can run the end-to-end test. While this is creating the network, which is about a minute or two, I will show you the end-to-end test. The end-to-end test is the same case that I have in the mock test, but with some modifications. So I told you Convector is based on adapter. So the way that you specify that you are using the mock or the fake ledger is by using the mock adapter. The same thing, you can specify how it's going to communicate with Fabric, for example. And this is the pretty good thing about Convector. You don't really develop your contract, your controller's model thinking about Fabric. You just develop your contracts thinking about data and business logic, and the Fabric specific things come from the adapter. So on the day of tomorrow, we have actually developed adapters that talk with, for example, a MongoDB database instead of Fabric. So you can have the exact same code, the controllers and your models, just storing and computing data, and the overlayer, the underlying blockchain infrastructure or data infrastructure is just specified by adapter. In this case, I'm using the Fabric controller adapter, I'm specifying which user I'm going to make the calls. I'm specifying what is the channel where my code is located, what is the chain code name in this network, where are the identities, the key material, the keys and certificates for my users and things like that, and what organization is going to be using the calls that I'm going to make. So as you can see, okay, the Hurley command already finished. So at the end, it will say, okay, I created the star script. I created 2 organizations, org1 and org2, and I created 3 users per organization. So admin, user 1, user 2, and user 3. And I created a channel. All this can be specified by when you create a network with Hurley. You can specify how much channels you want. You can specify how much users and organizations you want. Actually, in this case, I'm specifying I want 3 users by passing this flag to Hurley new. And that's why it's creating just 3 users besides the admin. All right, so now that the network is installed, I can run npm run cc start and coffee, because my name is the project is named coffee. You can see that in the configuration file here. In this configuration file, I'm specifying I want to include both controllers in a single chain code. So I'm specifying, okay, I'm going to install the coffee CC, which is this one, and the participant CC, which is this one, the road to those specified packages, and the class where you can find the controller for that. Doing the CC star, as I tell you, it will build, since this is TypeScript, it will build the source code so it can just transpile that into JavaScript code. It will also come and generate this chain code coffee package in here folder package, which is the compile Convector package. Fabric supports JavaScript contracts, and that's why Convector can run on it. Convector is nothing special or nothing different from a regular JavaScript contract. At the end, it will just compile as a single JavaScript contract, and you can see the source code of that in here. You can also check out the package JSON of what it generated. You can check out the source code of Convector that gets injected into that smart contract, which is just the basic underlying functionality to init and invoke the contract. So all the source code of that is in here, and you can see in packages that it copied the coffee CC and the participant CC, and it copied the distribution, which is plain JavaScript code. You can see this code in here. It will also generate this JS map and the D.ds, so you can have source maps while you are debugging, so you can still see your original source code, even though it was compiled to JavaScript at the end. This is going to take like a minute. It's about to finish, I think. All right, so let's continue seeing the end-to-end test. All right, it's already instantiated, yeah. All right, so I will run npm run test E2E. So I can run the end-to-end tests of this project, which is this one that I'm talking about. All right. Yeah, the rest of the test is mostly the same thing that I have in the unit test that I already explained. So it will still create 3 participants. It will create a fake batch, well, the initial batch, and it will create the other 3 batches, combine them into a single toast batch, roast batch, sorry, and at the end, just output the same exact output, the console that we saw before. The difference is that this time, it is running on an actual blockchain network. So if I go to this path is provided by Hurley. Fabric creates CoachDB for you to have available for all your peers. So in this case, I'm seeing the information about the first peer. If I go to the port 5184, I will be able to see the CoachDB for the second peer. And if I have n peers, I will be able to see all the different CoachDBs from each of those. The other thing that I can do to show you, we are running on a real blockchain is doing, you can do here, Docker PS, and you will be able to see that we have 2 CoachDBs effectively running, 2 certificate authorities, 1 for each of the organization, 1 orderer running, 2 peers running this network for organization 1 and organization 2. And now that I have installed the contracts, you can see I have also the contract container that Fabric creates for me, which is the coffee version 1.0, coffee 1.0. This is because I just installed that. If we jump to the end-to-end test, okay, it already completed the execution. It showed me the same thing, batch, blah, blah, blah. It's composed of these 3 participants, these 3 batches. If I go to the CoachDB, I will be able to see all the data that I produced. So let me see, example, this is, all right, let's look by the ID. I want to see the information from the roast batch. So I copy this ID and I paste in here. I can see the composition is made of some IDs. It was created, the owner is actually an ID. If I can just go and copy this ID again and look for that. You will see it is ID of the participant toaster. And for example, the composition, I can go and look for this ID as well. And you will see is the composition is the grain batch ID and the toast batch ID. I can copy those 2 to see the original information of those. So I can see, okay, this batch was generated in San Jose. These are the producers, the participants that were involved in this batch. This is the price, the quality, the weight of this batch, etc., etc. So with this, I have a full traceability of the whole data. And since in the models I specified them to be read-only, they cannot be updated from using the same contract, and I can trust this information is pretty immutable. So yeah, this is, I don't know if anyone has any questions so far about the whole flow.
So, hey Diego, thanks for the presentation. The question I had, that you said that it supports, because it's running on Java and on JavaScript, and it supports Fabric. So does this also support any other languages so far, or like the entire infrastructure that you guys are providing for multiple clouds? Does that scale up the other formats as well, or is it just this one right now?
Right now it's just as JavaScript. We are thinking though on adding support to multiple languages, because since it's based on TypeScript export this tree that it's called AST, okay. Which right now it compares to JavaScript, and we installed that on Hyperledger Fabric, but we can export this as a WebAssembly, and from WebAssembly we can transform this to Solidity or to Golang or to any other languages. We haven't done so yet. Mostly all the people in the community is using just Fabric so far, but we are though thinking on adding support to other blockchain technologies.
Okay,
So
the format that you showed, that you said that, for example, @read only and all those decorators that you had for all the variables, does that automatically comply with the auditing that happens for a general smart contract? Because, for example, you can have a reentrancy problem, right, for different smart contracts. So does this handle all those edge cases by default, or is there something we have to code in?
So on Fabric, each contract that you install on a ledger, it will have its own like data source. So any ID that you store using a single chain code, and if you try in a different chain code using the same ID, they will be separate by Fabric itself. So it cannot be updated by any other external chain code. So you can just trust that the data that you will save with this chain code, it won't collide with other chain code, and you can trust as well that any other chain code cannot update your own data.
Okay, all right, thank you.
All right, guys. So a couple of other things that we have for Convector. I show you just the controller and things like that. We also have a REST API generator. So we have a package. Let's see here. I think I have it in the root. Yeah. So we have this package, conf REST API. That what it will do is you specify an API JSON file, and in this API JSON file, you basically tell it you want to expose the function register from this controller as a per post. And the same thing for this, the function get for the participant controller as a verb get, etc., etc. So you specify all the paths that you want to generate, and you just run conf REST API generate. I think it was like this. I'm actually let me actually look for the signature. I most of the time forget about that.
Was this Swagger?
It generates a Swagger API, yeah.
Okay.
Yeah, so you can see that the source code is also open source, so you can just check it in here. You generate it just doing, conf REST API, generate API. You specify the project that you want to use. In this case, in my case, is the coffee project, and you specify the config file. The config file is this config file, so it can know where it can find each of the controllers. So if I run that command, what it will do is auto-generate me this server folder in here. The server folder already comes with a Fabric controller initialized, pointing to, well, by default to the Hurley folders where to get all the users and all the crypto material and all stuff. But it can be overridden by using environment variables. This API, what it will generate is these dynamic routes where you can just call /participants/register, for example, as a post method. And what it will do is, if you come to the source code of this, it is based on Express. It will expose a Swagger endpoint for you, but it will basically do the same thing that we were using on the EndtoEnd test, as like having a controller, calling the register function, and calling all the parameters that we need. And this will make the invocation to the ledger, et cetera, et cetera, et cetera. So in order for me to show you how this works, I want to show you first how you end up like deploying this on a real environment. So I went ahead and this is a little bit about Forma, the platform that we have. So in Forma, remember, you can create multiple networks on different kind of ledgers. In here, you can just come and see the Fabric setup, and you can create new networks just by specifying, okay, I want to create a new network for coffee traceability, and I want it to be like a multi-cloud. I don't have any cluster configured right now. Configure a cluster is really a straightforward process. You just specify your cloud provider and provide some credentials on how to connect with that. right now I can just specify, okay, I want a new environment fully managed by WorkCivu, and I want, in this case, to create a fake organization just to demonstrate the process of this network. I already have a network created for you. Yeah, this is it. So at the end, I created a network. A format by default creates the network using Fabric 1.4.1, and it will use draft ordering. So I have two orderers in my network, and I also have two peers on my network, which is one for each of the participants of this network. It creates a public ledger, a public channel, where I already have this coffee contract installed. Installing a new contract is as easy as just specify the name of your contract, upload a zip containing your source code, select, okay, I want a Node.js or a Golang. I want to specify the version. I can specify some initial arguments for my contract, or we can also support private data collections for it. As I told you, I already have a contract running in here. It's the same source code that I have running already. So I went through and installed, create a service account for my participants. I just created one. I will be creating or two. Ali's password will be 1234. And let me see, for example, I had Bob, Alice, and Josh. Okay, so let's create the three of them. I don't want to save that. Josh, 1, 2, 3, and 4. Okay. So I have three participants in here. I will be, I want to enroll them. So by default, Fabric format creates the user for you, but it doesn't hold the key identities for that. So I will come here and enroll my users so I can have the users to run this on a production network. Let me see real quick. Here, Fabric helpers, yeah. I want to run, let's see, npm run enroll. And I want to pass Alice, password 123. And if I remember correctly, the organization is this one. Yeah. All right, so this is going to, oh, let me see. I think 1, 2, 3. Oh, my password was 1, 2, 3, 4. Okay, so this will generate the credentials for Alice, and I will also generate the credentials for Josh, which I created, right? Josh. Okay, so this will create me the certificates. You can see this, the private keys and the public keys in here. These are only mine. These are only local. Format doesn't have access to this. So we just copy these. This is a helper that we have to generate those crypto materials. I will be pasting that in here. Paste. Let me see. Select this and push. And let's paste this in here. Right, so I have all my crypto material here, and I have this env file pointing, okay, I will be using Bob's identity, and it is present in this folder, and this is my network profile. The network profile is just a file specifying all the components of my network. Right now, it specifies I have two orderers, it specifies the peers, and I can control from here which peers I want to use for querying, for example, Chinko query. So I want to use, in this case, I'm acting as this organization, and I want to specify, hey, so just use this just use this peer when I make any query calls to the ledger. So on Convector, when I specify in the function $query on any of the functions, it will just, again, not send the full transaction, just send a request to this peer to emulate the data and bring me that back. And yeah, you can see all the information about the full network profile in this file. What I can do from here is go ahead and start a server. Do that by doing npm np external run. It is start. And I'll be passing server and string. So let me see. I actually already did this with Bob. So let me change this to Alice. And from here, you can see, well, let me show you the Swagger endpoint. Oh no, sorry. Yeah. So the Swagger endpoint is in another branch of the project. So by default, it doesn't generate the Swagger. We're about to generate that. That has been in beta for a couple of weeks, so I think it's pretty stable now. But yeah, sorry. This project that I generate, it doesn't come with Swagger enabled. But what we can do is go to Postman, and register a new participant. So in this case, I'm registering Alice with the D3456. You can see it's localhost 8000. I'm calling the participant register with a post method, and I'm specifying which is the participant. So you can map this. You can go for the participants. You can see the participant controller has a register function. That's why I call participant is the base key, and register is the name of the method. And since this is a post, I'm sending the participant parameter as a key in this JSON file. So if I go and send the transaction, it will go to the Fabric network and send a transaction. That's why you see it takes a couple of seconds to generate this, to actually store this data. You can see response 200, okay? We can go to Forma and see, okay, I want to see if this data has correctly been registering here. I can see, I can click go to console. This will open my coach to be, I think, this is, rename. All right, it will ask me for a user password, which is protected. So I'll just put this in here, login, authenticated. All right. So I can go to the public coffee channel that I have in here, and I can see I have participant Alice being correctly registered as a participant. This is the type, and this is the fingerprint. This is the identity. So this is what I told you. It was going to use that this sender, it has this fingerprint, and this fingerprint only belongs to the public certificate of my Alice user. So no one can just like update this field without having Alice certificate. And for Fabric to accept the transactions with Alice certificate, it has to be signed with Alice private key. So I can use this as a mechanism to identify users and authenticate them inside the chain code. I will now go and, okay, I can make a participant get with ID 3456. So I will do so. And okay, so we got the information back with the ID, the name, the identity, etc. I want to go and register a green badge. So I have a /coffee, which is the controller coffee, and I want to create a green badge. So I will create a badge with ID. Let me see. I will see 5678. With location in San Jose. The height will be, I don't know, 50 meters above sea level. The producer will be this Alice producer. And this will be the price and the weight, yeah, and the quantity is premium, etc. Okay, so I will send a transaction using this. One thing you can also see in Forma is that we have metrics about everything going on their ledger. So you can see here that the block count increased from 6 to 7 with the last transaction, which was registering the participant. You can see some other data, like for example, the chain codes that you have installed, the orders that you have installed. Since we're using Graph, it specifies me which is the leader of this network. And you can see the active connections between the orders and peers, for example. Let me see. Okay, it ended with a 200. Okay, so let's make a get all batches. Coffee get all batches. So I can get all the batches. I previously registered a batch for BUP. So at this time, I will be able to have two batches. Yeah, one is with ID 2345, which was produced by BUP. This is the ID for BUP. And we have a new extra batch, which is the producer is 3456, which is Alice BUP. And by doing so, we can just continue like querying all the functions that we have auto-generated in this REST API. This is all the functions that we have in here available to do so. Just one last thing I think I want to specify. You can all the things that you can just do in the interface with format. You can just do all of those with the REST API. So you can programmatically create networks, create channels, create participants, install contracts, etc. You can do all that stuff from this Swagger API, or you can just call directly from your code API. So if at the moment I want to deploy all the end-to-end tests that I did on Convector to a continuous integration, I can just create a network on the fly on my continuous integration, install the contract, run all the tests, tear the network down, and be sure that my contract is running successfully. So I can do all that stuff via API without having to have any manual intervention. So yeah, I think with this, we cover most of the tutorials that I have present today. I don't know if anyone has like any questions regarding any of the topics that I covered today. I will be pleased to answer the questions.
I don't see any questions in the chat. I think there are no questions. If there are any questions, going once, going twice. Okay.
No, all right, awesome. So I hope it's all clear. So yeah, please. So just to finish the presentation, Convector is a really pretty straightforward framework. We try to focus on make you think only about your business logic. As you can see, we get rid of all the complexities of setting up a Fabric network locally for you to test, and we set up all the basic unit tests and end-to-end tests for you, so you don't really even figure out how to do so. And in the chain code on the controllers and model, we abstract everything so you can just focus on your business priorities instead of just like figuring out how do I parse this kind of data and things like that. So we have a community, a pretty active community on Discord. We have a lot of members actively like asking questions and answering questions in there. So I want to invite you to join our community, so you can just get to know better the framework and the community around it. And if you have like an idea or want to collaborate with the framework, we're always open to that. So thank you very much for your time. And I think this will be the end of the presentation, right?
Thank you, Diego. So these links are going to be, can you send a separate email to participants of the meeting with the link to the speaker deck probably for the presentation that you did?
Sure.
Yeah, and so I did get the GitHub, so I went on the GitHub page that you said and during the talk. So, but yeah, it'll be really handy to have these things available to participants along with the recording, because some of them were, commuting at the evening time. But since we had this meeting, I'll be glad to forward this to my peers. Thanks, Diego. Thanks again.
All right. Thank you very much again for your time and for your host.
Thanks everyone for joining. Bye.